Hi students. So in this video I will be talking about a method called GETSIZEOF. I will show you examples, I will explain its internal working and all these stuffs. So we have come to the end of our roadmap to complete comprehension. We are just 2 steps away. In my next video I will be talking about another method called time it. Okay, so let's start with GETSIZEOF. So this is a system method, or you can say this method helps us to directly talk to Python interpreter, and the module which helps us to use this method is SYS module or system module. So this is a built-in method of system module. So to use it we have to just import sys, and this method takes one argument, the object, a target object, and it returns size of the target object in bytes. Okay, so let's talk about how this GETSIZEOF internally works. So as I said, GETSIZEOF takes an object, a target object as its argument, and returns the size of that object in bytes. So before I started GETSIZEOF, there are actually two types of object in Python: built-in object and external object. Built-in objects are those like int or float, means they doesn't have any reference object as its element. But in case of external object like list or set or dictionary, they have reference object as its element, means, or they contains some other objects as its element. So let's take an example. First is num equal to 5, then list equal to 1, 2, 3, 4. So as I said, this is my built-in object and this is my external object. So as you can see, this list contains 4 integers. Okay, so these integers are also objects. So this is the difference between these two. And in case of GETSIZEOF actually returns accurate result for built-in objects, but doesn't return accurate result for external object. Means, okay, so before that, every object has a method called __ SIZEOF attached to it, and this __ SIZEOF returns the size of that object. That means this GETSIZEOF actually uses this method internally. Also adds some overhead to it. I'll talk about this. So as I said, this is external object, and in Python, so I'll talk about memory management in Python in a separate video, and there I'll talk about, there are two concepts: reference counts and garbage collection. So the objects that are actually handled by garbage collector, this GETSIZEOF adds some overhead to the size of this object. Means in case of built-in object, if we use num dot __ SIZEOF like this, and sys dot GETSIZEOF num, this will return same output. Okay, but in case of external object, if we do like this, list dot __ SIZEOF and print sys dot GETSIZEOF, and if we pass list as its argument, we have not actually imported sys yet, so let me import sys. Okay, so first let me print this also, then you'll be able to see the difference. Okay, now if I run this, see, so here as I say, these are built-in objects in float, and this is the reason GETSIZEOF returns accurate result as SIZEOF. See, 28, 28 in both cases. But this is not external object, and this is the reason GETSIZEOF is giving some more value than this one. So GETSIZEOF returns that this list is of 88 bytes, but SIZEOF returns that this list is of 72 bytes. So what is the correct result? Actually both are, because this SIZEOF returns the exact size of this list. Okay, but this GETSIZEOF actually adds something more to it, and as I said, this overhead or this extra thing is called garbage collector overhead. I will not talk about this much in this video. As I said, I will make a separate video where I will talk about memory management in Python, and I will explain all of these terms, this garbage collection and difference counting, in that video. So for timing, just remember that this GETSIZEOF is actually we can say this get size of equal to underscore size of plus garbage collector overhead. And this holds true for the objects that are handled by garbage collector. And those objects are external objects. So built-in objects are not handled by garbage collector. So these extra 16 bytes actually comes from that overhead. Okay. But there is another issue, and that is these 88. So okay, so now if you think that these 88 bytes is actually the whole size of this list, I mean, you are just making a big mistake. And the case is, there is something more to it. So this size of actually returns size of this container, but it doesn't consider its children objects. So you can think of like that this is my parent object and these are my children objects of this parent object. So in memory, how it happens is, these are referenced through this parent object. So these objects are not actually directly attributed to this object. So what are directly attributed objects? So as I said, we can divide object into two more types, and that is directly attributed and reference object. So directly attributed objects are those. So let's say I have defined a class, my class, and inside of that class I have defined two more objects like int and string. So let's say I have defined num equal to 5 and string, my string equal to some string. So these num and my string are actually directly attributed objects of my class. Okay, but these are, so let's say I have so this list, as I said, this is object. So it has some inherent property with it, some objects, directly attributed objects, some methods that are attached to it. So this get size of, or this underscore size of, considers only those things. So as it is an iterable, like list, set, dictionary, all iterables, so they actually internally maintains a table to keep track of all its elements. So this size of considers only those things, like that table, the directly attributed objects, only those things, and it doesn't consider the objects that are referenced through this. So in this case, these integer objects are not actually considered in this case, in case of SIZEOF or GETSIZEOF. And this is the reason this 88 is not at all the whole size of this list. So if we want to get the whole size of this list, so what do you have to do? So as you can see, this list contains 4 integer objects, and we know size of integer object is something more, as I said. So let me show you what is the size of an integer object. So let me first go to my Python shell, and if I do like this, sorry, this one is size of. So in Python, int is of 24 bytes. So this is actually size of this integer object, and we know that int is my class and this is the instance of that class or the object of that class. Okay, so in Python that means int is of 24 bytes. Here we have 4 integer objects. So if we add, if we do like this, print sys.getSizeOf, I'll just copy this thing. And add the extra, add the size of the children objects, like this one, 4 into 24. As I have already seen, this int is of 24 bytes. So this is actually the overall size of this list. Let me show you. So these 184 bytes, so this is actually the exact or overall size of this list. So you can do like this. This 4 is nothing but length of this list, and this 24 is nothing but int dot underscore size of. Okay, now let me print. See, so this is how we get overall size of an external object. Okay, so now you can realize that if we have a list of, let's say, float objects, so this int would have been replaced by float. Okay, so that's all about GETSIZEOF and underscore size of. Okay, so before I leave, I want to show you something. I have already said that I will show you practically that generator is more memory efficient than list. So let me take an example. So let's say I have a list and I'm using list comprehension. So LE for LE in range, let's say 1000, and here Same thing, just make this generator and I leave already in this, and this will be parentheses to represent that we are generating a generator. Okay, I have talked about all these things before, so you can watch it in my playlist. They are already present. Okay, so let's talk about these two codes. So here we are generating a list from an interval. Range is an interval, and here we are generating a generator object. We know that this is generator expression, and this returns generator object. So first, let me show you the output. Print list1 dot underscore size of. I am not using get size of just to avoid the overheads. I want to show you the basic difference first. So print and next is generator and dot underscore size of. Okay, so just see the difference. This list is actually taking 9000 bytes, but this generator object taking 96 bytes. So just see the difference. Almost 1000 times more. Okay, so the reason is this list allocates memory for all the elements. I have already discussed about it, and I'm just briefly saying here that this list allocates memory for all the elements of its sequence. So here the sequence is 0 to 999. So in memory, for all the elements, memory allocation is done. But in case of generator, it only returns a generator. So this generator object, Gen1 is my generator object. So only this generator object is stored in memory, and it uses underscore next method internally to keep track of the sequence. So this is actually the difference between generator and list, and you can realize that actually this list, this size is not the overall size. This size is only the size of the container. So as we have done here, if we do the same here, so let me do this. This is actually the size of the overall list. Also I have not considered the extra overheads or the garbage collector overhead, but just see the difference. Okay, so this is why generator is more memory efficient than list. And yeah, that's all about today. In my next video I will talk about timing module, which helps us to understand the execution time difference between two codes. So and using that module I will show you the difference between. So as you have seen here, this generator is more memory efficient than list, and using timing module I will show you that this generator is actually time efficient also than this list comprehension. Okay, so that's all about today. Bye bye.